Hello everyone, this is Bill PKG and today I'll be discussing about the WebRTC and probably I'll going to the very depth of it, like enough for you to understand how it is working actually. So this video might be a little long, be patient and just look what is up. I'll be sharing a code, giving you an example. So probably you can try it later and just understand what is going on. This is a book which you can later on have a reference to and actually give a good reading because I won't be reading it word by word in this video. I've read this book and this is really the best resource you can have to just have a getting started because this book goes to quite a depth but not go touches everything but it will give you a good idea what is going on, like enough for WebRTC. So, what is WebRTC? Like this, this heading, the WebRTC is actually just a protocol. Like I should say, it is combination of protocols. It is not a very new technology, I would say. Like it is combination of quite lots of old technologies which even dates to 2000 or 1990s or something like that. So there are quite lots of benefits. You can just read up here. The most interesting thing which I did got to know and I really loved was NAT traversal. I didn't knew about this thing. Okay, so we'll get back to this. So WebRTC actually is quite useful when you want to some do some kind of information sharing and it should be really fast. You want it to be really fast. You can actually do the communication so fast. Maybe you want to share some kind of video, some kind of live stream, some kind of thing like Google Meet uses it. Whatever meet or video sharing service you are using, most of them, the good one would be using WebRTC at that. So WebRTC actually utilizes, it does utilize this. I, yeah, let me get to this first. Something called as UDP, User Datagram Protocol. It is a fourth layer protocol, transport layer protocol. It is probably unreliable because it's like if two parties want to communicate, the sender will send the packet and the receiver will receive the packet. But if anything happens in between, this protocol is not taking charge of it. If something happens, if it is lost, if it is destroyed, whatever, probably you have to take care of it. And you can actually decide because suppose if there is some kind of live streaming you are doing the live stream, the pictures are going up there, flashing again and again and again, maybe 60 frames per second. For some reason, one or two pictures get lost, or maybe a set of maybe just 1 second of video just gets lost. Does it even matter? Because no one wants to see what happened before, like what happened in past. Everyone is willing to see what is happening right now. That's the whole thing. Everyone wants that because that's the purpose of streaming. Suppose if there is bad internet or maybe bad connection or something like that, and I lost a second of picture, second of video. I don't want to see it. It lost. It's lost. I want to see what's happening right now. Don't show me what's going on. Like what happened in past. So this protocol is actually unreliable and quite fast. There are lots of stuff you can actually read about it. see the packet format and stuff, source IP and stuff. Okay, we won't don't get too much deep in this, but yeah, that's whole stuff. And okay, this is hole punching. I will be discussing about it later. So that's the whole thing which is around the WebRTC, and I will say this is actually using quite a lot of stuff which is really old, say early 2000 and as brand new right now. Really, it's a really humble technology to have something looking quite new and really amazing how they just combine. Okay, so it happens in four steps, like the communication. Suppose there are two party, like two devices, you want to communicate them. So it will be happening in four stages. So first stage is called as signaling. Second step is called as connecting. Third is securing. Fourth is communicating. So what is signaling? In the signaling state, let me just uh, yeah, just draw something. I don't know. Maybe it just make more sense to draw something and show. That's how usually I do it. Suppose let's make a person one, and let's see a person two. Okay, don't go on my drawing because I'm doing it with my mouse. So in the signaling state, what happened will this guy, the one, he will actually try to, like, let's actually draw a gnat. There is a gnat because the real use of WebRTC is with gnat. Like it's fun. It's really fun. Let's have two layer of gnats. Uh, With gnat we can actually have so much of beautiful information. So suppose this guy is under the gnat and this guy is uh, under the gnat too. And this is the public internet. Okay, mm, that's it. So what happens is this guy, this guy, this what he will do is he will actually collect all kind of information about his surrounding, like what NAT he have, how to communicate through this NAT, how to make a hole and communicate through this NAT and stuff. He will actually try to collect all kind of information, this information, and this information is actually called SDA. Okay, session description. hmm Maybe I can get the name. Sorry, SDP. SDP. Okay, this is called a SDP. I don't know where did I get A, but okay, fine. This is called SDP. That's fine. Session description protocol. Okay, like we'll create a session description. Leave the protocol. Okay, we'll create a session description. Okay, so this session description will actually have information about how to communicate it through this NAT. If you want to talk to this guy, you need to understand the session description to actually communicate. And now what this guy will do is this guy will create an offer. Okay, offer session description. Okay. Now this session description will somehow from some way from something just fly in the air and land on this guy. What I mean is, actually, it doesn't matter. It is off, like out of out of whatever technology you want to use. Maybe just send it through a mail. Take a pigeon, get it on his leg, or maybe fly a pigeon, or just do a WhatsApp. Let two guys talk to themselves. So he will just create a session description offer and he will send it to this guy. Beautiful, really great, really great. And the same way, this guy once he receives the session description offer, he will actually create a session description answer. Okay, and this answer will again fly in the air, just keep flying in the air and land to this guy. Amazing. Whatever way, it will just get up to him. And this, as you can just intuitively think about it, is it will be describing how to control, like how to hold this stuff and get to get to him, to get me. That's the whole thing which is going on. So once the both party know what is happening, they will actually have description of their local description, local SDA, local SD, and okay, I say SDA answers, session description answer. I was saying, fine. So in some way, what will happen is these these both guys will get to know how to communicate to each other. You know what? One interesting thing which I will tell about it is this this what is going on. Okay, this landing of information and stuff. It is it is done through two technologies. One is stun, hmm, and second one is ice. Yeah, cool, really cool. Okay, so these are done through stun and ice. If you just get up here, actually stun. Where is there any full form of this guy? Maybe session. I just was reading it somewhere. So it is session traversal utility for NAT. Stun. Session traversal utility for NAT. So actually, what is the purpose of this guy is this stun actually is like their. Can I create a new page? Yeah. So stun is just like this is an ad, this is an ad, maybe one more NAT, something like that. There is a server of stun server, there is a client, stun client. This client will make a request to the stun server. The stun server can see what is the IP and port at this particular point, and stun server will, in his response body, he will fill the detail of this and whoop, given to that. That's it. Simple. So it's a way to know what is my public IP address and port on this NAT. And there are a couple of types of NATs. Some do allow the traffic, some doesn't allow the traffic. We can look about it later. But the thing is that the whole stuff which would have happened, like which would have happened, not always, but have, yeah, which would have happened is this, to know how to, like how to communicate to this guy. This guy will ask a server which is in public IP address that what you can see, how you can see me, what I look like. on the public IP address, because NAT, this outer NAT or maybe the layers of NAT will never let this guy know what it looks like on public IP address. So this stuff will help him understand how it looks. So that's stun, beautiful, beautiful. Okay, then we have ice. Okay, so what I said is how to communicate to this guy, whatever thing you can use, maybe different kind of stuff. That all is actually managed by this ice, ice, and is written on session description. If I could show you an example of session description, would be here. This is an example of session description. Okay. And in session description, you can see there is something called as candidate. So candidates are how like different ways of communicating to that server. Like I should say that client. Okay. Okay, one more thing I will tell you is actually WebRTC is a peer-to-peer network. Like if you are using WebRTC, it will be between two people. Both side have to do some kind of initiative. For example, up here offer answer, that is peer-to-peer network. Everyone is involved in some kind of stuff to make it happen. So there is the peer-to-peer network, and we saw the ST session description. We saw signaling. What is signaling? We saw the SD, uh, SDP, and then there is uh, there are more stuff like media session and description. What is answer offer? We talked about this thing. This is the format. Can I show you types of mat? Mhm. See, I will tell you that I have seen it somewhere on this on the NAT mapping. Yeah, this is what I was searching for. So let me tell about NAT. Hey, if you know what is NAT, then great. And if you don't know what is NAT and you would be thinking what exactly it is, it is a translate like network translation layer. Like it will translate the network. Suppose this is a public internet in our middle, okay, and we have a client, okay. In this public internet, we don't have enough IP address. This is what we are taught. Like, okay, we don't have enough IP address, so we create our private internet too. And for every request, what I will do is I will map my address, IP and port to a public IP and port. Okay, I'll map this and send the request whatever way I want to send. That's the whole purpose of NAT. Okay, so what could happen wrong? The thing is that there are different policies of NAT, and every NAT is doing some kind of work, some kind of filtering. There could be thing like like there could be a thing maybe NAT is restricting to I will check for IP address whenever a response comes. I'll check for port whenever the response comes. Like that. So see, endpoint independent filtering, anyone can use the mapping. The address dependent filtering, when IP address would be mapped. Address and port dependent filtering, when IP address and port will be mapped. I will tell you for a disclaimer, not a disclaimer, maybe. Let's talk about it. So, if there is no restriction, because I will be getting to know about, I want a good color. Yeah, because I will be getting about myself, getting to know about myself through this stun. If that is the thing, if I'll be getting to know about myself in stun, then the the responding body, like the one which will be responding, would be the stun, and then this NAT will actually keep track of IP address of stun and port of stun. If IP address is restricted, then this guy can never ever give a response. You get me? If port is restricted, then this is kind of impossible. Maybe you can find some ways for IP address, I don't know. But i- if it was written like if B attempts, then the mapping will ignore. You can see. I'm not sure, but maybe you can find some ways to just get the thing happen. But if the things are restricted, you can't do anything. That's the simple thing. If that is the case, that is the case, you can actually do something called as uh, turn, turn, T U R. You can use something called as turn server. So turn server is like you're gonna pass the traffic straight from here to here. It is like having a normal web server in between both. Then the thing, then if that is the case, if you are using turn, then I don't think WebRTC is the best option, because that's the that's the thing where you have boundary. You don't have to use until and unless you want to have luxury of having a good API of sending media and stuff. You don't want to use. So we saw stun, what is stun? We saw mapping. We saw turn server. We saw ice candidates. You can read this stuff, how the address is relayed, address is mapped between the turn server and the traffic is sent between these. That's cool. That's cool. So this is the first one was signaling, which we talked about. The second one is connecting, that is just connecting, as you can think of connecting to clients, making a connection. And to do that, you can use turn server. If they got the session description, they got to know about each other, they will just connect themselves, try to do whatever. And one more thing I will tell you is it will be happening in like stages, like steps. First signaling will happen, then connecting will happen, then securing will happen, then what was the last one, the communication will communicating. So until and unless the signaling has been done, connecting will never ever happen. Until and unless the securing has been done, communicating won't happen. Like it have to be completed step by step, 100%. That you can see up in the second line. Beautiful, beautiful. Now securing, you would be using some kind of cipher, There would be ways to share the cryptographic stuff. See, this is actually a very popular algorithm. A Fallman exchange allow two users to who never met before to create a shared secret securely over the internet. Like two people, two two users, they don't know each other. They just securely share information. Secret. So that's the thing. Beautiful. DTLS, it would be used to uh, s- encrypt and decrypt. Like it's like brother of TLS, the one we use in TCP. You might have heard HTTP connection, HTTPS. I would say HTTPS connection. So it would be used to encrypt the message or some kind of random data, arbitrary data, what you can say. And then we have this for sharing media. You see, exchanging media. Media would be video, video like that. Okay, real-time networking. It will be talking about jitter congestion issues, how things are. You can see there is a jitter frame. The packet will come. Jitter buffer will actually keep track of the frame, join them, and get to the decoder. That's the thing. Like you want to do it fast, so there will be so many parts, so many things you want to use RTP. Okay, there is not much I want to talk about it because if I get into it, it will be quite a big topic for us. Then let's talk about communication. Have some kind of packet structure to let me get you to this is a JavaScript API. Hey, let me actually show you a code instead of making things very boring. You might be waiting for the code. So, in this, I created a sender and a receiver. There are two JavaScripts being loaded. I don't know, I just wanted to do it in web browser. So, let's talk about whatever we used. Hmm. Okay. First of all, to start a WebRTC, in JavaScript, we have RTC peer connection. It is a class which contains all kind of whatever protocol we talked about, stun or turn, DTLS or other. So this is the one we gonna create a peer connection. Then we want a data channel, a channel on which we can communicate. So there is lp.create channel. We talked about what is ICE candidate. It is way in which one client knows how someone else can communicate to me. So these are ICE candidates. Then once the ICE candidate is found, it would be logged. Like I want to just see which ICE candidate because I'll tell you it will be useful. You have to copy that like this is local description. Okay, so I want to print the local description. I'll copy it and give it to the receiver. You remember I said send it whatever way, maybe WhatsApp, pigeon. Then on data channel connection, like once the data channel gets connected, I want to know it is being connected. On message, if there is a message, I want to see what messages came. Then I create an offer. You see, I set the offer as local description. Great. And once it is done, I want to print offer created. Beautiful. Then let's get to the receiver. What I will do is once the offer gets created, it will many ICE candidates will be printed. Okay. And out of those, like I would say local description would be like session description would be printed. And out of those session description, I will take the latest one and get to this receiver. In receiver, you can see same code, same peer is there, same ICE candidates. This one is a little different. And then I take offer as prompt. The offer would be the session description, the latest session description of the sender. Okay. Now let me talk to about this chunk of code. This is on data channel. Once this connection will receive a data channel, what it will do is it will log that I got a data channel. Then it will store it in the this peer only. You can store it anywhere, doesn't matter. For just sake of simplicity, I did it like this. Then this is actually event like data channel event. In data channel, from the data channel event, you can get RDC data channel, that is e dot channel. Then you want to set these two events again. When the data channel is open, it will say open. When message comes, it will say message came. Then we set the remote description of this guy is which is offer got here. Once I set the remote description, I got the right to create an answer. I should say I can respond with an answer. So to respond with an answer, I will create an answer, and once I create the answer, it will again like previous time start printing the local description one as I get the ICE candidates. Then I gonna copy that. I gonna come up here and you can see answer. I use timeout because in the web browser, if you don't use timeout, most probably what you will get to is uh, you won't be getting like you won't be able to copy the ICE candidate, the local description. So I said a timeout. There is the set local description, set remote description again, and after setting the remote description, we wait for some time and send hi. Like not with it. This send hi. Beautiful. Let me get you to here. So this is our sender. You can see actually a pop-up here. See. So you can see that these are the ICE candidate which got printed. I actually copied the latest one. Now I gonna refresh this one and just this is the receiver. I copied from there and now I just want to paste it up here and press OK. Beautiful. I get some of the ICE like some ICE candidates and I printed the session description. You can see RTC session description. I copy it up from here and paste it up here and beautiful. Data channel open, sending hi. You can see a message event has occurred. The data is high. You can see the data up here. Beautiful. You can actually see up here too. So that's all. Let's send something else. DC. You remember we name this guy DC. So DC dot send hello. If I send hello, that's what is needed. The hello goes. Okay. So this is using the WebRTC protocol. You are just using the WebRTC protocol. I'll be adding the link of this code in the description. And you remember up here, I made a hole. Okay, this hole, I use this term because the process is called UDP hole punching. It is like punching a hole between a UDP, like between a NAT, not UDP, between a NAT. It is like punching a hole on the NAT through which you can communicate this guy. And this is done using stun. You can do it differently too. You can make your own server, doesn't matter. But usually we use stun. So I think I did talk about everything from communicating, securing, everything has been covered. I think. See, first steps, signal, connecting, securing, communicating. Fine. Well, that's all for today. Thank you for listening. It was a long session.